Now let's move on to problem B. Again, notice in problem B, we are set up for substitution more than elimination. So the best way to start off substitution is to start out with the easiest equation is to get a variable by itself. Well, the easiest equation to get a letter by itself is the second equation here. So we'll start out with that equation and we'll get one of the two variables by itself. It doesn't matter which. Now this is a line, so we're already pretty used to getting y by itself. So let's go ahead and get y by itself. Well, how do we get y by itself? Well, we're going to first of all move the 3x, so we'll add 3x to both sides. That will just leave us with a 4y equals 3x plus 2. Now divide both sides by 4, and that will get you y equals, well, you have to be careful when you divide both sides by 4. That means you're dividing everything on both sides by 4. So that gives us a 3/4 and a 2/4. Although we do have to be careful once again because the fraction 2/4 does reduce. It reduces to 1/2. So we get that y equals 3/4 x plus 1/2. Now the thought is using substitution, we can take this y equals 3/4 x plus 1/2 and plug it in wherever there's a y into the equation we haven't used. So we're going to be plugging that into the y up here in the other equation. The equation x squared plus y squared equals 5. So we'll replace that y with the 3/4 x plus 1/2. Notice in our formula that y is, notice it's squared. So we can't forget that we're going to have to square it. What does it mean to square something that has parentheses around it, like this? Well, it means that there's going to be two of them, that there will be twin copies of them. So there'll be a 3/4 x plus 1/2 times another 3/4 x plus 1/2, which means, how do we multiply those two? Well, we're going to multiply those two by doing FOIL. Well, the first part of FOIL has us multiplying the 3/4 x times a 3/4 x, which gets us 9/16 x squared. Because you'll multiply the tops of the fractions and the bottoms of the fractions, and then x times x will just get you x squared. The next part in FOIL has you multiplying the 3/4 x and the 1/2 to get 3/8 x. The next part of FOIL has us doing the other 1/2 and the 3/4 x to get another 3/8 x. And then the last part of FOIL has us multiplying out a 1/2 and a 1/2 to get a 1/4. That's just the foiling. I'm still not done. We still have to combine like terms. Well, the first set of like terms that you have is you do have a 3/8 x and another 3/8 x, which when you add it up becomes a 6/8 x. Now you can reduce that to 3/4 if you'd like, or let's just go ahead and get rid of all the fractions at once. Well, I see denominators of 16, 8, and 4. The least common denominator, though, between 16, 8, and 4 is 16. So what we can do is if we want to get rid of all the fractions in one fell swoop, we can multiply each and every piece on both sides of the equation by 16. This will clear all of the fractions. Well, if we multiply that first piece by 16, it becomes 16x squared. Then multiplying the next piece by 16 will actually cancel out the 16 and just leave us with a 9x squared. The next piece will actually reduce the 8 into 16 2 times, so we'll have the 2 times the 6, which is 12x. And then the last piece, it's like having a 16 times 1, which is 16. Divided by 4 is 4 as your last piece. And don't forget we multiplied the other side by 16, so 5 times 16 is 80. Again, we aren't quite done. We have to combine our like terms. Our first set of like terms that we get after this is a 16x squared and a 9x squared, which gives us a 25x squared. We have a 12x that wasn't touched, and we have a, we have a 12x that wasn't touched, and we have a 4. But notice we're ending up with something that's quadratic. Well, if it's a quadratic equation, just like the last one, it needs to equal 0, so we might as well move the 80 back over to the other side by subtracting 80 from both sides, which now, that negative 80 when combined with the positive 4 here, gives us a negative 76. Now, yes, you can try factoring, but with such large irregular numbers, I think your best bet is to go ahead and try the quadratic formula. So, question is, what is the quadratic formula? Well, if you don't remember it, as a reminder, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, the first thing, negative b, is going to be our negative 12, because b was positive 12. Then we have our plus or minus symbol. Then we have our b squared. Well, again, if b was 12, b squared will be 144. Then we have our negative 4, and then our a. Well, our a is, the 25 times your c, which we came up with was negative 76. And on the bottom we have 2 times a again, and a we said was 25. So the question is, mathematically, what do we really actually start with? Well, we'll start by making sure that we've already done the exponents underneath the square root, is now the next thing underneath the square root we'd go after is the multiplication that's listed. So we'd end up by working on the multiplication, the 4 times 25 times negative 76. Now, beware here. You're set up in a trap a little bit because you have a negative on the 76 and a negative sign in front of it. Well, the negative times a negative will actually turn into a positive. And then all we're worried about is, what is the 4 times the 25 times the 76, which we do get 7,600 here. Everything else will stay the same. The only other thing that you could do that would be really small would be, multiplying the 2 times 25, which is 50 out on the bottom. Let's see what else we can do next. Working right along, we've got almost the entire inside of the square root figured out. The only thing left that we can do is actually do the addition that's inside of the root. So if you do the 144 added to the 7,600, you'll get 7,744. Now what's amazing is you actually can do that root. The square root of 7,744 is 88. Now notice, there is something special about the quadratic formula. Because there is a plus or minus symbol in the quadratic formula, we will most times get two answers. So, reading out the two answers, the one with the plus first, well, the one with the plus first, if I just look at that answer, is negative 12 plus 88. All of that divided by 50, that's your first answer. Then your second answer is using the minus sign. Negative 12 minus the 88 all over 50. That's your second answer. But you actually have to do the math if you can. Well, on the first one, negative 12 plus 88 is positive 76 over 50, which, be careful, can be reduced. Those are both divisible by 2. So if you reduce those by dividing both by 2, you actually get 38 over 25. So that will be one of our two final answers. On the other one, we had a negative 12 minus 88 over 50. Well, if you do the top, negative 12 minus 88 gives you negative 100 over 50. Well, that actually divides out evenly. Well, 50 goes into negative 100 as negative 2. So we end up with our two answers, our 38 over 25 and our negative 2. Beware, though, you are actually not done. These are just your solutions for x. So that means that one of your solutions is going to have x equals 38 over 25. And the second solution will have x equals negative 2. But you still have to find the corresponding y values by plugging them back into the first part of your substitution. When you plug both x's back into the original equation, making sure that you actually get common denominators and everything, you will get the following solutions for y. You'll get 41 over 25 for y, for when x equals 38 over 25, and when x equals negative 2, you'll get a y value of negative 127 over 50.